Good day, students. Welcome to this JSS 1 Basic Science lesson on sound, its properties and uses. From the beating of the Dundon talking drum at a Yoruba ceremony to the call to prayer echoing across a Kano mosque, from the distant thunder of a Harmattan storm to the cry of a newborn baby, sound is fundamental to human communication, culture, and experience. By the end of this lesson, you will be able to define sound and describe how it is produced and travels, compare sound and light as wave phenomena, explain pitch, loudness, and quality, timbre, describe the properties of sound, and state the uses of sound and the effects of noise pollution on health. Let us begin. What is sound? Sound is a form of energy produced by vibrating objects and transmitted through a medium, solid, liquid, or gas, as longitudinal waves, compressions and rarefactions, alternating areas of high and low pressure. Unlike light, sound cannot travel through a vacuum, it needs particles to vibrate and pass the disturbance along. Proof: ringing a bell inside a vacuum jar, as air is pumped out, the ringing becomes inaudible even though you can still see the bell vibrating. How sound is produced? Any vibrating object produces sound: vocal cords, human voice, vibrating guitar string, drumhead struck by a stick, speaker cone moving back and forth, a tuning fork, wind passing through a pipe, flute, organ, air column in a horn, trumpet, Nigerian horns used at traditional festivals. How sound travels? Sound travels as longitudinal waves. Particles vibrate parallel to the direction of wave travel, not perpendicular like light/electromagnetic waves. Compression, region where particles are pushed closer together, higher pressure. Rarefaction, region where particles are spread further apart, lower pressure. These compressions and rarefactions travel through the medium, carrying the sound energy, but the particles themselves do not travel with the wave, they vibrate in place. Sound requires a medium. Travels through gases, air, most common, liquids, water, whales communicate through ocean, and solids. Putting your ear to a railway track lets you hear an approaching train far sooner than through air. Solids conduct sound better than gases. Speed of sound in air at 20 degrees Celsius is almost equal to 340 meters per second. In water is almost equal to 1,500 meters per second. In steel is almost equal to 5,000 meters per second. Sound travels faster in denser/more elastic media, usually solid, liquid, gas. Properties and characteristics of sound. Frequency, pitch. Frequency, number of complete vibrations, cycles, per second. Unit, Hertz Hc. 1 Hertz equals 1 vibration/second. High frequency, high pitch, treble, piccolo, flute, whistle, baby's cry, soprano voice. Low frequency, low pitch, bass guitar, thunderclap, baritone voice, dundon drum at low note. Human hearing range, approximately 20 Hz to 20,000 Hz, 20 kHz. Infrasound, below 20 Hz, too low for humans, detected by elephants and whales for long-distance communication, also from earthquakes. Ultrasound, above 20 kHz, too high for humans. Bats and dolphins use it for echolocation, used in medical scans/ultrasound imaging of babies in the womb, very common in Nigerian hospitals. Amplitude, loudness. Amplitude, the maximum displacement of a particle from its rest position. Larger amplitude, louder sound. Loudness is measured in decibels, dB. 0 dB equals threshold of hearing. 120 to 130 dB equals pain threshold, can cause permanent hearing damage. Examples: whisper is almost equal to 30 dB, normal conversation is almost equal to 60 dB, busy Lagos traffic is almost equal to 85 dB, church/mosque speaker is almost equal to 100 dB, Nigerian generator close-up is almost equal to 95 to 105 dB, jet engine is almost equal to 140 dB. Quality, timbre. Timbre is what makes different instruments/voices sound different even at the same pitch and loudness. A guitar and a flute playing the same note at the same volume still sound different. This is because they produce different patterns of overtones/harmonics alongside the fundamental frequency. Reflection of sound, echo. Echo, reflection of sound off a hard surface. Minimum distance for echo in air, about 17 m, so the reflected sound reaches your ear at least 0.1 s after the direct sound, the minimum delay the ear can detect. Reverberation, many echoes blurring together in an enclosed space, concert halls, large Nigerian churches. Uses of reflected sound, sonar/echolocation bats and dolphins navigate by echolocation, emit ultrasound pulses, detect echoes, sonar, sound navigation and ranging, used by ships to detect the seabed and submarines, ultrasound in medicine. Absorption of sound. Soft, porous materials, carpet, curtains, foam, acoustic tiles, absorb sound, reduce echoes. Hard, smooth surfaces reflect sound. Soundproofing in recording studios uses soft materials on walls, floor, and ceiling. Doppler effect. When a sound source moves toward you, the frequency, or pitch, seems higher. When it moves away, it seems lower. Experience it when a car or Okada horn passes you, the pitch drops as it recedes. Named after Christian Doppler. Applications of sound. Music instruments, all based on vibration, strings, pipes, membranes. Communication, human speech, telephone, convert sound to electrical signal and back. Sonar, mapping ocean floor, locating fish shoals, used in deep-sea fishing off Nigerian coast. Ultrasound imaging, pregnancy scans, kidney stone detection, very common in Nigerian hospitals. Bat echolocation, dolphin communication. Seismology, detecting earthquake P waves, compression waves, and S waves, shear waves. 3 examination questions. Question 1. A student shouts near a cliff and hears the echo 3 seconds later. If the speed of sound is 340 meters per second, how far away is the cliff? Sound travels to the cliff and back, so the total distance is equal to 340 times 3 equals 1020 m. Distance to cliff equals 1020/2 is equal to 510 m. Question 2. List 3 differences between sound and light. A. Sound requires a medium to travel, cannot travel in vacuum, light can travel in vacuum. B. Sound is a longitudinal wave, particles vibrate parallel to direction of travel, light is a transverse wave, particles vibrate perpendicular to direction of travel. C. Speed of sound in air is almost equal to 340 meters per second, speed of light is almost equal to 300 million meters per second. Light is about 880,000 times faster than sound. Question 3. Explain why you see lightning before you hear thunder. Lightning and thunder are produced at the same moment, an electrical discharge. However, light travels at approximately 300,000 km per second while sound travels at approximately 0.34 km per second. Light reaches your eyes almost instantaneously, sound takes much longer to travel the same distance. The further away the storm, the greater the delay between seeing the lightning and hearing the thunder. Rule: every 3 seconds between flash and thunder is almost equal to 1 kilometer distance to the storm. 3 common mistakes. Mistake 1. Confusing pitch and loudness. Pitch is determined by frequency, how fast the object vibrates. Loudness is determined by amplitude, how far the particles are displaced/how much energy in the wave. A drum can produce a loud, low-pitched sound, a whistle can produce a quiet, high-pitched sound. They are independent properties. Mistake 2. Thinking sound travels fastest in air. Sound travels fastest in solids and slowest in gases. Steel, 5,000 meter per second, water, 1,500 meter per second, air, 340 meter per second. Solids and liquids are denser, particles are closer together and transmit vibrations more efficiently. Mistake 3. Saying sound travels in vacuum. Sound cannot travel in a vacuum. The experiment in class, a bell in a vacuum jar falls silent as air is removed, even though you can still see it vibrating. Astronauts in space cannot shout to each other, they use radio, electromagnetic communication, which does travel in vacuum. Summary. Sound, energy produced by vibrating objects, travels as longitudinal waves, compressions and rarefactions, only through a medium, cannot travel in vacuum. Speed, still water, air, 340 meters per second in air. Frequency, hertz, pitch, high frequency equals high pitch, low frequency equals low pitch. Amplitude, loudness, dB. Timbre, unique quality of a sound. Human hearing, 20 to 20,000 Hz, infrasound, less than 20 Hz, elephants, ultrasound, greater than 20 kHz, bats, dolphins, medical imaging. Echo, reflected sound, distance equals V times T/2. Sonar, uses echoes to map seabed/locate objects. Sound versus light, sound equals longitudinal/needs medium/340 meter per second, light equals transverse/no medium needed/3 times 10 meter per second, noise greater than 85 dB, hearing damage, generator noise, a major Nigerian health concern. For homework, A bat emits ultrasound and receives the echo after 0.04 s. Speed of ultrasound equals 340 meters per second. How far away is the object? B. List 3 uses of ultrasound in Nigeria. C. Compare sound and light in a table. Attempt a quiz on your LMS. Keep exploring the world around you. Visit Lightech Academy at academy.lightech.com.ng. Until next time.